What if we could command the sky? Imagine humanity holding the planet's thermostat. We could cool cities during deadly heat waves or redirect rain to parched farms. This is the promise and peril of geoengineering intentionally altering Earth's climate to counteract global warming. For decades, we've fueled climate change with unchecked emissions. Now, as disasters mount, we're considering interventions as dramatic as the problem itself. The debate is no longer just about cutting emissions but about seizing control of planetary systems once thought untouchable. Geoengineering tempts us with a technological fix, but also forces us to confront our relationship with nature. Could we really build machines to scrub the sky or fleets to brighten clouds? Scientists and policymakers are racing to find out. We stand at a crossroads, the risks of inaction versus the unknowns of radical intervention. The question is no longer if we'll consider these options but how we'll manage them. Geoengineering means deliberately manipulating Earth's climate on a massive scale. It's a plan B. If cutting emissions isn't enough, these interventions could help. The field splits into two main approaches: solar radiation management, SRM, and carbon dioxide removal, CDR. SRM aims to cool the planet quickly by reflecting sunlight, like putting a parasol over Earth. It doesn't fix the root cause, just the symptom. CDR tackles the problem directly, pulling carbon dioxide from the air and storing it safely. CDR is slow and costly, but offers a more permanent solution. SRM is fast and relatively cheap, but temporary and risky. Neither is a silver bullet. Some experts argue we'll need both. SRM to buy time, CDR for the long-term fix. These strategies represent a fundamental shift, from adapting to climate change to actively engineering the planet's future. The stakes are enormous, and the choices we make will shape civilization for generations. Geoengineering is no longer science fiction. It's a real, urgent debate. The most discussed SRM method is stratospheric aerosol injection, mimicking volcanic eruptions to cool the planet. High-altitude aircraft could release reflective particles, creating an artificial sunshade. It's simple, and models suggest it could halt global warming within years. Another idea, marine cloud brightening, using ships to spray seawater and make clouds more reflective, cooling targeted regions. Even more ambitious, space mirrors to block sunlight before it reaches Earth. Still science fiction, but technically possible. The appeal of SRM is speed and affordability compared to unchecked climate change. But the risks are huge. It doesn't stop ocean acidification and could disrupt rainfall, damage the ozone layer, or trigger other unknown effects. SRM is a tempting emergency tool, but it's a blunt instrument with global consequences. Dimming the sun may buy time, but it's a gamble with the planet's systems. The question isn't just can we do it, but should we? The world must weigh the promise of quick relief against the dangers of unintended consequences. Carbon dioxide removal, or CDR, aims to reverse warming by cleaning up the atmosphere. Direct air capture uses giant machines to filter CO2 from the air, storing it underground or using it in products. Bioenergy with carbon capture and storage, BECCS, grows plants to absorb CO2, burns them for energy, and captures the emissions for storage. Nature-based solutions like enhanced weathering or ocean fertilization try to speed up natural carbon sinks. Each method faces massive challenges: cost, scale, and potential ecological disruption. To make a real impact, CDR would need to operate at the scale of today's oil industry. The Intergovernmental Panel on Climate Change says CDR is essential for limiting warming, but warns of its limits. CDR is slow, expensive, and logistically daunting. But it's the only way to truly undo past emissions. The cleanup will take decades, vast resources, and global cooperation. Unlike SRM, CDR addresses the root cause, but the path is long and uncertain. The world must decide: invest in a massive cleanup or risk runaway warming. The scale of the challenge is staggering, but so is the cost of inaction. Picture the year 2050. Humanity deploys only SRM. Jets maintain a chemical veil, halting temperature rise, but CO2 keeps climbing. Oceans acidify, and we're locked into endless intervention. Any pause triggers catastrophic warming. Now imagine a CDR-only world. By 2070, thousands of carbon capture plants and vast bioenergy farms finally lower CO2, but only after decades of disasters and huge environmental costs. Or a hybrid future. In the 2030s, leaders deploy SRM as a stopgap while racing to build renewables and CDR. By 2080, as CO2 falls, SRM is phased out. Each scenario brings trade-offs. SRM stabilizes temperatures but risks ocean health and technological dependence. CDR is slow, costly, and disruptive, but more permanent. The hybrid path offers hope, but demands unprecedented global trust and coordination. None of these futures is a utopia. Each is a world transformed, shaped by hard choices and new risks. The decision isn't just technical, it's ethical, political, and deeply human. Do we accept the risks of radical intervention or the certainty of climate chaos? The path we choose will define the planet for centuries. Geoengineering is no longer a distant possibility, it's a choice we must soon confront. The stakes nothing less than the future of civilization. The world we inherit will be the one we engineer or the one we allow to unravel. The time to decide is now. Geoengineering opens a Pandora's box of risks. SRM could disrupt weather patterns, shift monsoons, or trigger droughts, creating new winners and losers. The moral hazard, the promise of a quick fix, could sap the will to cut emissions, making the crisis worse. Ecological impacts are unknown. SRM might damage the ozone layer, while CDR could harm oceans or convert forests to fuel crops. Governance is a nightmare. Who controls the thermostat? What if a nation or billionaire acts alone? There's no global authority to manage these technologies, and unilateral action could spark conflict. The greatest danger may be our own hubris, intervening in systems we barely understand. Before we act, we must confront the ethical, political, and ecological risks head-on. Despite the risks, research into geoengineering is advancing cautiously, and often controversially. Scientists argue we must understand these tools before crisis forces our hand. Small-scale experiments like Harvard's ScopeX or Climeworks carbon capture plants are testing the science. Transparency and global oversight are essential. Secret projects will breed distrust and backlash. We need new models for governance, public engagement, and ethical review. The debate is not for or against geoengineering, but how to manage it responsibly. Proponents see it as a necessary tool. Critics warn of hubris and distraction from real solutions. The real reckoning is with ourselves. Are we ready for this power? Before deploying these technologies, we must build the ethical and legal frameworks to govern them. The future of geoengineering and the planet depends on our collective wisdom, not just our science. What if we could control Earth's climate? It's within the realm of possibility, but not without cost. We might hold the power to cool the world, but also the power to destabilize it. The key question: can humanity handle that kind of power with wisdom? Fascinated by the science of climate control? Then subscribe to Earth&Beyond for weekly deep dives into the most compelling questions about our planet and beyond. What do you think? Should we have the power to control Earth's climate? Drop your thoughts in the comments. We read everyone. Don't forget to like the video if you learned something new, and share this with anyone who's curious about the future of climate technology. Like thought-provoking science content? Watch our next video. Could we survive if the sun suddenly vanished? Or check out what if all the ice on Earth suddenly melted for another wild climate scenario?